And welcome back to your regularly scheduled programming. I am John, your master coder. Just kidding, I'm a regular dude. And on tonight's lesson, we're going to be doing a quick review of what we did last time. I think in the book itself, we're doing chapters 2 and 3. We're specifically targeting lists, which, like last time we talked about, was a grocery list. They hold different data types. We learned different things that you can do with the lists, transforming them, adding them, removing items, popping, appending, splitting. Part of the homework was to adding or inserting things into the middle of a list and even iterating over a list. I think we talked about with a for loop, adding things from the lists into a calculation together. No numbers? Okay. So I realized in a previous recording that the reason that I couldn't see the numbers, the row numbers listed on the actual IDE was because the aspect ratio was too big, so it was getting cut off or truncated, which is another fancy word for computer science. So a way that you can actually make sure that they're there is you can go to Tools. If you don't have it on yours, this is really important. Um, Give me just a moment. I think my recording is okay. It's fine. It just looked like it was being cut off. And we're gonna have to edit that out later. Or maybe not. So tools, and then, come on, John. Think, think, think. Is it tools? Window. I had it earlier. Options. So tools, options. Yes. We're looking for languages. This is not correct. That's not correct either. So tools, options, text editor, all languages, and then general. And then here is where we can find the line numbers option. So I can unselect it and it removes the line numbers. I prefer them to be on. So tools, options, text editor, all languages, general, line numbers. You can also Google it, um, typing in Visual Studios, how to, yada, yada, and then it'll pop right up, which is what I had to do during our short commercial break. So we talked about variables, we talked about lists. We did a little bit when it comes to loops. We did a for loop last time, which was fun. What we did was we iterated over individual elements of that list and combined them to sum them together. There are other things that we can do with the list as well. Tonight we're going to start with Boolean logic. Have you ever heard of Boolean logic?
I've heard the name
Boolean. There's a guy, can't remember his first name, his last name was Boole, invented this Boolean logic. It's basically all based on true false statements. Either it's true or it's false. And he actually invented this logic way before computers were even thought of, which was really cool. They applied the Boolean, sometimes called Boolean algebra, into computers, and they created something called a logic gate by using true and false statements to create circuits, which was really cool. There are the three different kinds of logic gates. They're going to be and, or, and then there's not, right? So,
is the capitalization added.
um, not for now. No, I'm going to say capitalization does not matter. So, if, and this is just thinking out loud, if I'm hungry and I have food, then I will eat the food, right? So both of those things have to be true in order for me to have eat the food. If I am hungry and I have no food, then I cannot eat the food. If I'm not hungry but I do have food, I still won't eat the food, right? Both of those conditions have to be true in order for the and to be true as well. Or is one or the other of the logic case. So if I'm hungry or thirsty, then I will take food or water, right? The analogy kind of breaks down, but if one is true or the other is true, then the overall assumption is that it's true. And then not just takes the reverse of it. So if I say that I'm hungry, but I'm really not, or a better example would be like if I ask my wife if she's hungry and she says that she's not hungry, I apply the not logic gate and assume that she is hungry and I have to go get her food, right? So that's for the recording. That's for you, honey. So that's the not logic gate. She says she's not hungry. Just apply the reverse to it. Go get her food. Might have to pay for that later. So that's just a little bit of logic gates. And that's going to come up a little bit later when it comes to our conditional statements. We're going to go straight into our if-then conditions, conditionals. So if X, then Y, right? So the way that we structure it, we're going to start with a variable. We're going to say name is equal to parentheses your name. And then we're going to have our conditions. So it starts with an if. I like how they do different colors. Okay, so if name is equal to John, print hello John, right? Cannot even spell my own name. Good grief. Okay. And what this does, kind of on a big scale, is and a lot of people like to put this in parentheses. You can, it's really just a personal styling choice. But if whatever is on the inside of the parentheses or whatever comes after that keyword if is true, then it will do whatever is inside the indentation. During one of the first two lessons that we talked about, or that we did, we talked about how white space is important when it comes to Python as a programming language. It won't do everything that's inside this indentation if what's inside these parentheses isn't true. If the parentheses aren't there, it's just whatever that condition is. If it doesn't return true, then it won't print. Yes. So I'm not going to run it, but we know that name is John. So name equals John. It's going to print the true. Now notice we have two equal signs. This is called a comparison operator. It's comparing one if it is the same value as the other. So if I had, oops, come on now. There we go. Other name is equal to John. This might seem a little silly, but I cannot. There we go. So what this is going to do is it's going to do the same thing. It's going to check if the value saved in the variable name is the same or is equal to the value that's saved in the variable other name. We know that it's true because they're both John, right? We're checking for equivalence. If we left just one equal sign, we get our little red squigglies, red squigglies. I say that it's yelling at us because this is an assignment operator. Like in row 9, we're assigning the value of John to the variable name. We have to have two equal signs in order for it to be a comparison operator. We're checking to see if name is equal to other name. Make sense? Sure thing. So two equal signs is a comparison operator. And it looks weird. It's like a long equal sign, but there are actually two there. Now, what this is going to do if we tried to run it is it's not going to print out hello, John. I keep getting these pop-ups. I like having the pop-ups whenever I hover over something, it tells me kind of what it is. But if I'm just explaining, but anyways,
Question, just
yeah,
to recap.
sure.
So, if name, one equal sign, quotation, John, quotation, that would work, right?
If I put this inside those parentheses,
If you just put, yeah, if name equals John, then print hello, John.
correct.
Okay, just to recap. Without the double,
Without the double equal sign.
without the double equal sign.
In a different programming language, it would accept it because what we're doing is we're now assigning that value of name to mean John. But right here, it's confused. It's like, why are you doing that?
Okay, okay. Just want to clarify that. You're good. Moving on.
Sure. But if we say that it's equal to the other name, which is not true, it won't print. So we're going to go ahead and just execute that here since we haven't executed code. Run code, executed code. I guess no surprise there. Nothing happened. Now, this exclamation point, some people call it a bang, which is fun. This is to mean not. So that is not. So this is equals, comma. The exclamation point is not. So what it is not equals. Does that make sense? So it's checking to see if the first name is not the same as the second. And if that is true, it's still going to print out the message. We know that the first variable is not the same as the second, so it will execute the code and print out our message. I'm going to remove these parentheses. It'll still work without it. We're going to add another variable. We're going to say age is equal to 35. Okay. So far we have if name does not equal the other name. And I'm going to put or. Notice it's a keyword. Age is equal to 35. Actually, instead of equal to, we'll do greater than 21. I think I'm going to leave the parentheses on here for right now, just for clarification's sake. Except I'm going to put even more parentheses. Again, the parentheses are not required. It's just the way to group your thoughts together. It's a styling choice only. In some programming languages like C++, you absolutely have to have them. But with Python,
So
user
even on
friendly.
print hello, John, you don't have to have parentheses?
I don't know. I've never tried to print without actual parentheses there. But specifically inside an argument space like this. That's a good question. So what this is going to do is it's going to see if the first condition is true or if the second condition is true. I'm going to turn this to double equals so that it's checking to see if one is the same as the other, or if age is greater than 21. So what this is going to do is it's going to return false. I'm just going to put an F here. We know it's going to return false, but a little bit further down, we know that it's going to return true because age is greater than 21. So because that second condition returned true, it's going to execute the code inside of the indentation. Make sense? The if statement. Both of these would have to be false in order for the code on the inside to not run. So if we change age to 15, nothing's happening here.
Right.
Make sense? And using this style of logic, you can group multiple different conditions together. But before we continue a little bit further, what I'm going to do is I'm going to show you the next thing. We're going to say else print not Andrew or older than, I guess it would be younger, wouldn't it? Younger than 21. Technically, it would be group. Less than or equal to 21. Okay. So because this is going to return false, that's going to return false. It's not going to execute what's on the inside of here. What is going to happen is it's going to print out this else. We're going to step through the code so I can kind of show in real time. Oops. Okay. I goofed. I'm going to redo it. What I did was I stepped over the condition instead of into it. I'm going to step into. Oh, it does the same thing. It's not a function. All right. So because it stopped here and then it verified if this or that were true, because it wasn't, it didn't go here.
Right.
So instead, which is another word that you can use for else, but else is the key word there.
Right.
So if this is true, then do the thing. Instead, you can do something else. So else, do this other thing, which is what it's doing now. We're going to print out the rest of the message. Not Andrew or, come on now. I keep losing my mouse. Here we go. Not Andrew or less than or equal to 21. I'm going to put this back to 35. Re-execute the code. Oh, and it stops. Huh? Oh, I don't have the F keys on here. We're going to step. Because this returned true, the hello John is going to print. There we go. Hello John. So that's if, or, we looked at not a little bit ago. We're going to do and. So both have to return true in order for it to work. You have to both be hungry and have food in order to eat, right?
Correct.
So the name has to equal Andrew and the age. We're just going to change Andrew to John real quick. So if John equals John and the age is greater than 21, print out hello John. And it does, because both return true. Both would have to return true in order for the hello John to print.
Right.
So now if I put the not here, if name does not equal other name, and this has to equal greater than 21, one's going to return false, the other's going to return true, so it's going to print out whatever is in the else,
Right.
not Andrew. My variable names are kind of going off the rails, but this is where we're at. The key takeaway, not to focus on the variables, even though I am, is to focus on the logic, right? If one thing is true or another thing is true, do the thing. If both have to be true, then you can do the thing. If one of the two are not true, then don't. And you can add additional variables and conditions ad nauseum, just as many as just more than you really want to. Now let's say we wanted to do separate conditions. We wanted to do a printout of hello John if the name matches. We're going to put this back to Andrew. And then we're going to do a secondary condition if that first one is not true. Let's skip the names. Let's do ages. So age, if the age is, let's just say the age is greater than 16. Or I guess it would be greater than or equal to 16. We're going to say driver, right? If you are over 16, equal to or over 16, you can drive. Well, if you have a license. We're going to do another variable using a data type we haven't actually discussed yet, and that's on me. This is called a Boolean variable. We're going to call it has license. And this is going to be equal to true for now. A Boolean value has one of two values, true or false. It can change depending on your code, but it will be one or the other. So if the age is greater than or equal to 16 and, or I guess it would be or, has license, then print driver. Notice how we don't have a conditional here. We don't have a comparative operator. No greater than or equal to, no equal, right? Because this is a Boolean value, it's going to automatically put that true or the false into that slot. And again, remember with our or statement, if one or the other is true, it's going to continue through the code. Does that make sense?
Yes.
Now let's say we'll do elif. Elif is short for else if. So that means if this first condition is not executed, then we can enter in a secondary condition. So elif will say name. Again, the parentheses are just for collecting thoughts. Right. Elif name equals John, colon. Notice how we have a colon at the end of each logic condition. What that does is it lets Python know that this is in the middle of an if statement. And eventually, later, it will be a loop. And then I hit tab. I'm going to print out John drives whatever and whenever. Period. So I don't have to be 16, even though I am over. And then finally, if the second condition fails, if it's actually Andrew, then do the final thing. So I'm going to arrange it to where the first two fail and it just prints out the last one. and we'll see how it goes through it. So we're going to say the age is 8. The name is lowercase John. Cases matter with strings. If we wanted to, we could do name dot lower, and that would return the value of the name. Or I guess technically it would be name dot title if I wanted it to work as true. Except it's a lowercase t, I think. Yeah. But we're not going to do that. We're just going to leave it as it is. That was kind of a cool point I just kind of glozed through. You can manipulate the variables inside your if statements. So if I'm getting a user password and I know that it can consist of capital and lowercase letters, and I just want to compare it all as lowercase, I can do name.lower or password.lower and do that direct comparison to kind of avoid any fat finger or user issues. So we've got has license. We're going to just turn this to false. Notice that it's a capital letter. It's also not just T or F like I kind of set up here. So we made it to where when we execute it, we should be able to step through because this returns false. This returns false. So it's going to skip that. Name does not equal John with a capital letter. So we're just going to execute from here. We'll step through. Okay. Starting. Step over. So it did that comparison. False. Now we have elif, short for else if. Name equals John. We're going to step over. It failed that condition, so now it's going to the default value, which is the final else, which is going to print not Andrew or greater than or equal to 21, less than or equal to 21. Yeah, my print statements are turned quickly into garbage. Stop. That was weird. Anyhow. So that is that. The background. So again, to recap, we have our variables established in the front. Then we have two different comparisons. We have if this or that is true, do the thing. If the first set of conditions fails, check the third condition. If that's true, then do the second thing. If both fail, which is what that final else is, kind of a catch, print not Andrew or this other mess. I use this in one of my classes for like a security login. Like I imitated a coffee shop, which is one of my favorite things to do, a kiosk, and we'll go into menu-driven systems after a while. But I had to have the user take an input, and if it was the right password and they answered it wrong so many times, then it was like intruder alert. It was really neat. But using this if statement logic, I was able to develop that. So if the password is equal to the real password, or the user input was equal to the real password, then give them access. Elif, they had so many tries, then prints out an annoying message. Yeah, not too bad. This is big. Okay, now that we've gone through some of the craziness, I'm going to get rid of it. So pause real quick for the screen if people need to type it out. I'm reviewing the lessons. Part of the reason we put the videos online so that I don't have to keep a giant document of everything we've typed out. Now we're going into loops. Loops, right? We talked about Boolean logic, true, false, showed the variable. We talked about and, or, and not, and how they work with if then conditional statements. We talked about indentation, and now we're going into loops. We talked a little bit about loops last time, but not a whole lot. So for, this is called a for loop. That's a good place to start. So for each in list, it's kind of like what we did last time. Print, oops, each. Now we have to have a list variable. Why is it highlighted blue? Oh, it's a class. Let's say it's a special keyword. So we're going to go, we did books last time. I don't know. Let's do chairs. We're going to say chairs is equal to a list of chairs. Remember, lists are surrounded by the square brackets, separated each individual element by commas. So we're going to have a list of, we'll say 4 chairs. I think I could think of 4 chairs. Some nice spacing. Oops. That's just for readability. The computer doesn't care if there's spacing in your stuff. Well, inside your brackets and variables. It cares about, this type of spacing. As a matter of fact, this is exactly 4 spaces. One tab should be 4 spaces. 1, 2, 3, 4. Hello. Yep. But a tab just gets you there automatically. So the first chair, we're going to do folding. And then rocking. Lazy boy. And no, not going to use that one. Bench. Is a bench considered a chair? Who cares? All right. So it's going to take the chairs list, and it's going to say for each one of the elements inside the list of chairs, we're going to print that to the screen. Now you can say this is anything. You could say this is whatever that is. And then, oops. And then just put that here, and the computer's cool with it. There's a concept in software development or just coding in general called self-documenting code. I'm all about comments. This for loop takes in a list. Goodness, I can't even type. And prints each item in the list to the screen. You don't have to go off the rails like that. But if you have self-documenting code where it just does exactly what it says, it self-documents, you don't have to have a whole lot of comments. Comment your code for sure. But if you have self-documenting code where it's simple enough to look at and say, okay, so for each in chairs, print each. Notice how it didn't say print chair. I could do chair. For chair, in chairs, print chair. And what this is going to do, it's going to print the chairs to the screen. But I want to show you how it does that. So I'm going to look for my window. Where's my thing? I think it has to do with the screen recording. Come on. Oh no. There it is. Come on. No. Yes. Okay. So it prints out each of the chairs. That took entirely too long. I wonder what's going on. Folding, rocking, lazy boy, bench. You know what's cool about lists? Lists. What's cool about these for loops is you can do other things inside the loop besides just the one. So let's say we want to print, not with capital letters, we're going to print an extra space. Now this isn't something I've shown you yet. There are certain things that you can type into the double quotes that will tell the computer to do extra types of spacing, special characters. In this particular instance, we're going to do a backslash and then the letter N, lowercase. The backslash is located just above your enter key on traditional keyboard. So this is a new line character. Some people would call it like a carriage return character. It's back from the days when we were using typewriters. You would hit the right. It's my best impersonation. What this is going to do is it's going to print each of the elements in the list, and then it's going to give an extra line underneath. This is helpful when it comes to stylizing, if that's a word, your output, say. And it looks like we have more than one space, but really, if we use our cursor, it looks like two. But why? It's weird. How interesting. 1, 2, 3. Ah, I think what it does, let's see what happens when I do it like this. Plus, quote, backslash n. I think the extra print automatically makes it go on to the next line. Ah, there we go. The extra print makes it go on to the next one. So now we have just one space in between each of the elements. And then, funny enough, one at the end too, because as it hits the last item in the elements, it still puts an extra line at the bottom.
So I could just put the backslash n at the end of each of our prints on our last homework
Yes. Now, still inside the for loop, right? We're in the indentation. We can continue to combine the different things that we've learned. So let's say we have another if statement here. So I type in if, so chair is equal to folding. Then what do we want to do? We'll print, let's see here. Who uses folding chairs all the time? This class. This class's chair. And then we'll say elif chair, if chair is equal to rocking, print granny chair. Oops. And these pop-ups. Okay. And then finally, you don't have to have an elf. I'm sorry, an else. Not an elf. Santa Claus. But if we wanted to, we could say else colon. Notice how we put a colon at the end of each one of these so the computer knows to expect that extra indentation and to do stuff inside that indentation. And what's even more impressive is you can continue through and add extra things that you want it to do if the condition is true. So print, put them away when class is done. Granny's chair, take care of it. Else, we're just going to type the word pass. Now, pass is kind of a key word used. It's kind of like a placeholder. There's a concept called stubbing out whenever you're doing software development. If you have the ideas of what you kind of want your code to look like, you can write some pseudocode out. Let's say later I know that I want to do something with it, like say these chairs are weird or whatever. You're going to have the word pass. So we're going to just execute this code. We're not doing any breakpoints this time. And we just see what it came up with. So we have the folding chair, right? Because it printed folding on line 12. Then this class's chair printed because the chair was equal to folding. And then it printed out, put them away, And then we have the rocking chair, which was the second item in the element. It went through the first if and it wasn't folding, but it was rocking. So it printed out granny chair, right? And then it went back, printed lazy boy, line 12. It checked if it was still folding, no. Checked if it was rocking, no. So then it just went back up to bench, printed out the bench. See? Again, this was just an example of combining the if statements and elif into a for loop. We could very well just as easily go the other direction. So if the chair is equal to folding, then for, I don't know, the analogy breaks down, for however many chairs we have. Eventually what we're going to do is we're going to create a user interface, text-based, like a coffee shop. It's one of my favorite assignments, where we're going to be able to get in input from the user who's operating as a clerk at a coffee shop, to be able to take orders, to be able to ring people out. We're going to use math for that. And we're going to use these type of logic items in order to make that happen. Conditional logic. If the customer chooses small, then this is the price. If the customer chooses medium, then that's the price. Let's say they want a bagel or they want bacon. Then you sum it up and then they cash out. And you're good to go. You can even factor in how much change we have to give them. And we'll go through some of those things in a future lesson once we get these basic concepts down. For loops and if statements. Now, last time I know that I mentioned that loops and lists, for loops and lists go together like peas and carrots, because you're able to iterate over each item or element in the list and do something with it. We took our classic chairs list and we put extra conditions on it just to see, while still printing out some things. Any questions on this? Great. We will go on to the next thing. Okay, so we are done with tonight's lesson. Took a little bit longer than I anticipated, because I was all over the place. But today, the homework is going to be actually from the text. We're going to go through page 60 in the book, and it allows us to do different things with loops, which is really good. Page 60. And then, let's see. Yeah, we didn't get to most of this other stuff. So just page 60. That'll be it. It's 1, 2, 3, 4, 5, 6, 7 different mini assignments. Really need you guys to get the practice in. And just kind of skim through the chapter. If you get extra time, instead of scrolling, you can do some, I guess technically it would be scrolling because it's digital textbook. Just read your book. It's actually really helpful. And as always, I want to thank you so much for attending your regularly scheduled programming.